We're still looking at this A2 CCEA paper from 2011, fields and their applications, and we're looking at question 3, which is the capacitor question. Time constant of a capacitor is numerically equal to the product of the resistance and the capacitance, blah-de-blah-de-blah. Draw a circuit diagram that will enable the time constant of a resistor-capacitor network to be determined. So we need a power supply, we need some kind of switching, we need obviously a capacitor. So we'll have this side for charging it, and on the other side we'll have the resistor and some kind of ammeter, probably a microammeter. So something like this, with a capacitor, resistor, power supply, and an ability to switch from the charging side to the discharging side. Describe how the circuit should be used. Well, we've got a charging side, we've also got a discharging side. We'll probably label the terminals of the switch so that we know what side it's on. Switch it over to A to charge, and then you need to get a stopwatch ready. And what you do then is you switch it over to B and you start your stopwatch, and then you record the currents that are coming through at equal time intervals. Simple enough. So explain how the results from this can then be analysed to obtain a value for the time constant. So there's a direct way of doing this. You can just look at the values of the current and they will fall as the capacitor discharges. So you could plot I versus time. The capacitor value, the capacitor current, will decrease as the capacitor discharges. It's able to drive less current. And we're looking for the original I naught, what it was at the beginning, and we're looking for how long it takes to fall to 37% of that. So it's this 37% of the original I naught which will mark out on the time axis one time constant, and 37% of that will give you a second time constant and an opportunity to average them. So there's a simple way of measuring it. The other one is to take log of I, and you'll get a straight line graph then when you plot against time. You'll get a straight line, and the gradient of that will be minus 1 over the time constant. So that's the other way that you can use that data. So either a direct measurement like this, or a log graph like this. And that's that.